My name is Tom Darras. I'm the CEO and co-founder of Welinq, and today I want to tell you the story about how we started 2 years ago from developing very impactful new technology in our lab to creating a company and putting now products on the market. This company, Welinq, it's a startup which is based in Paris. It has been incorporated 2 years ago, and all the technologies I'm going to talk about are really coming for typically 15 to 20 years of research from our academic labs in Paris. So, as we've seen today, quantum computers, really, we expect for them to revolutionize many industry verticals, from pharmaceuticals, energy, or even solving some of our climate challenges. But what we really want for these quantum computers in the long term is really to be useful for all these industry sectors. And for this to happen, that we know that they need to be very powerful. And still, we are not there yet today. The quantum computers that we see currently on our ecosystem are still limited in computational power, and they cannot deliver entirely the promises for industry. The limitation comes from the fact that for this quantum computer to bring a computational advantage for industry, they need very large number of their physical constituents that we call qubits. If you look at the number, depending on the use case, it can go to hundreds of thousands, maybe millions or billions. We don't know yet because this depends on the use case. But what we know for sure is that it's going to be extremely challenging to have all these resources within a single quantum computer. If we look at what's happening today, the world's biggest quantum computers are limited to only a few hundred of qubits. And even if you look at the roadmaps of the providers of quantum computing, no matter the type of hardware you are looking at, neutral atoms, ions, superconducting circuits, spin qubits, we understand that we are going to face a technological barrier very soon in the number of qubits we can put within a single quantum computer. But very thankfully, there's a solution to overcome this problem. It consists of taking several intermediate-scale quantum computers and interconnect them in a quantum way, meaning creating entanglement between qubits of physically separated quantum computers, so that we can have equivalently a single quantum computers, but with many more qubits available for computation. And this idea of interconnecting quantum computers is now recognized as one of the most promising way to scale quantum computing. And what we do at Welinq in our company is that we develop and commercialize the world's most efficient solution to interconnect quantum computers. What is this solution? It's what we call quantum link. And this quantum link has three main features. The first one is that it's an end-to-end quantum link solution. It allows to interconnect quantum computers between them. It's hardware agnostic, meaning that it works in principle on any type of quantum hardware you are considering. And also it's full stack, meaning that we deliver physical interconnection between the quantum computers, but in parallel we develop all the software tools and algorithm tools to make sure that this link can be operational in real-world environment. For example, in the software aspect, what we have seen and heard today is that one of the ways to make sure that we can hybridize classical information processing and quantum resources is to work on the software layer to make sure that we can synchronize all this together. And we have a team at Welinq which is working on that. On the algorithm aspect, we understood very early that it's actually very different to run a quantum algorithm on a single quantum computer in a monolithic architecture or in an architecture where you have several quantum computers interconnected together. And we have a team which is dedicated to that, which works with end users of quantum computing on their specific problem, and we adapt the algorithm to ensure that they can provide computational advantage on this distributed architecture. And now let's look at how it works on the hardware side if you want to interconnect quantum computers. Well, we are going to do a bit of physics. You need to use what we call quantum teleportation, where the idea is that if you take these two quantum computers, no matter the type of hardware you are considering, to implement this, you are going to make it so each of these quantum computers emit a single photon, a state of flight, which quantum state is itself correlated with the states of the qubit carrying out the computation. And to understand this quantum teleportation, the big idea is that you want these two quantum computers to emit this photon, and you need to have these two photons interfere at a specific time. This is really at the core of what you need to do to interconnect them. But there is a technological limitation, is that it's very difficult to control the moment at which this photon is emitted by a quantum computer. And in most cases, when you try to have these two photon interfere, they actually never see each other. And then the rate at which you can create this entanglement between the quantum computers is so low that actually you cannot gain any computational advantage by doing this. And this is where Welinq enter into the game. What we propose at Welinq is to interspace in this network a very specific technology, which is called a quantum memory. And this quantum memory can be used to store the quantum signals emitted by the quantum computers and re-emit them in a synchronized fashion all at the same time. And then if you look at the numbers, the rates at which you create entanglement between these quantum computers are going to increase exponentially, not only with the fact that you use quantum memories, but also that you use quantum memories which are performant. And by performant, we mean quantum memories that do not lose the information on the way, because if you lose the information on the way, you have to repeat your protocol and you lose the advantage. And what we have done over our research is that we have developed world's most efficient quantum memories that we are using as a basic component of this full stack solution. And now I'm going to enter into the detail of it. But before that, I want really to show you all the application of these quantum links. The first one is really on this market of quantum computing, the fact that we can interconnect quantum computers between them to drastically increase their computational power. A consequence of it is that by increasing the number of physical qubits, we can shorten the arrival of error correction that we know requires huge amount of physical qubits to be implemented. Another application of our quantum link technology is the deployment of entanglement-based quantum network. Maybe you've seen the talk by Marc Kaplan this morning, that quantum memories is really a key technology to unlock all the application of quantum networks. And we are, of course, involved in many initiatives, and we provide products for the deployment of this entanglement-based network over hundreds of kilometers in length. And in all this application, Welinq has a unique positioning. First, we are the only company providing a complete and full stack solution for quantum interconnection. Then we develop products at industrial standard to ensure their deployment at the earliest. And finally, we rely on the best quantum memory technology in the world. So now you wonder, okay, what is this quantum memory he's been talking of? Sorry for the small issues in the presentation. Well, this quantum memory, it's typically a device that can take as an input quantum information in the form of light, and it gives you at the output the same quantum state of light with the same physical and quantum properties, but just this photon is delayed in time relative to the input qubit. And this delay can be programmable by the user. It's what we call an on-demand quantum memory. And then going back to the physics, how do you store this quantum memory, this quantum information? Well, by definition, light, you cannot stop it. Light propagates by definition. So if you want to store this quantum information, what you need to do is to convert the information from the light to a matter system, what we call a stationary qubit. And after your storage time, you can reconvert the information from the matter system back to the light. And if you make it that the process is coherent, you can preserve the quantum information of the way. This is really the basic principle of the quantum memory. But then what I was telling you is that you need quantum memories that do not lose the information on the way. And all this goes back to the problem of what is the ideal matter system that we need to choose to make this quantum memory. And the technological choice that we have made at Welinq is to use laser-cooled neutral atoms. We take atoms that we can trap with laser beams and magnetic field, and we have this cloud of atoms here that we manage to have levitating in a vacuum chamber. And this is the physical system that we use to store the quantum information. You have the photon arriving into this cloud and getting out then after the quantum memory. So what have I spent 2 minutes to explain you the physical principle of the quantum memory is really to show you that by using this technological choice, we have managed to push the performances of the quantum memory up to the first demonstration in the years 2000 to, in 2020, the world record in storage and retrieval efficiency of those quantum memories. These parameters that tells you that you indeed keep the information on the way. And in the community of quantum networks, this efficiency of 90% really understood as a benchmark for making quantum memories useful for application. And we got this result in our lab, and we decided then to create Welinq, a company, to take this technology out of the lab to make products, real deployment and demonstrators with providers of quantum computing. So then, to summarize what we are going to deliver in terms of product for our quantum memory at Welinq, it's a company that we started only 2 years ago, and this quantum memory will be available by end 2024. It will show the world record on storage and retrieval efficiency with storage time of few hundred of microseconds, allowing the deployment of entanglement-based quantum networks of more than 50 kilometers. What is very nice with neutral atom technology is that though the atoms at a very cold temperature, the entire system is working at room temperature. You can have your quantum memory, Welinq quantum memory, plugged in any power plug, even in your kitchen, supposing that you have a big kitchen, which is not necessarily the case in Paris. And this quantum memory, we are also working on making it compatible with any type of quantum hardware, neutral atoms, ions, photons, superconducting circuits. And we do not, sorry. A few years ago, it might have seemed a crazy idea to make actual products based on neutral atom technology. But we are not the first company in the world to make product out of this technology. Maybe you have heard of this pioneering French company in France that was called Welinq back in the day. And this company has managed to make gravimeters based on cold atom technology, which have now a technology readiness level of 9. These products are actually today deployed at the summit of volcanoes or even in Antarctica. And we based all our development on the maturity of this technology, and this is what enables Welinq to develop a product only in 2 years instead of taking 10 years. And in that endeavor, we have set up an industry partnership with Exail very at the beginning of our company. And really, this quantum memory, we do not want it to stay in our lab. This will be the product, our product of quantum memory that will be available by end of this year, quantum memory at performance. And based on this result, we are going to start deployment of this technology from 2025. We'll deploy our quantum memory on high-performance computing center next to the quantum computers which are currently being deployed and operated. And we are also going to deploy our quantum memories in test beds of quantum communication. In particular, Welinq is a partner of the initiative Paris Quantum Communication Infrastructure, where we have a test bed of quantum communication of few tens of kilometers in length, which is connected to Welinq's lab. And starting 2025, we'll have our products deployed in this network. And of course, and this is one of the reasons we are here today, we are very eager to look for collaboration to make other type of deployment of our quantum memories in France, in Europe, and all around the world. And in that endeavor, who are we working with today? Welinq has managed to transform a technological achievement into an actual product of quantum memory link, and we are now looking for commercializing our technology. We have 3 segments of partners. The first one, of course, providers of quantum computing, to which we can provide solutions to increase the number of qubits available for computation. And in that endeavor, we have today 3 partnerships on 3 different qubit modalities: neutral atom, photonic quantum processing unit, and superconducting circuits that we are going to announce in the coming weeks. We are also working with high-performance computing center to deploy our quantum memory on their premises so that we can interface our quantum memories with the QPUs they acquire and operate. And we work in that endeavors with high-performance computing centers around Europe to deploy our quantum memories there. And as well, we work with end users of quantum computing. Industry sector, which are eager to use high-performance computing and quantum computing, while we work with this industry to adapt their algorithms so that they are compatible with the distributed architecture of quantum computing that we are deploying. And in particular, we are today working in the industry vertical of energy, and we are going to announce a big project on the French side in the coming weeks, but we are also eager to extend our collaboration to target new industry verticals in the coming months. So then, this is a very nice story I'm telling you, but you might say, okay, who is this guy, and why is this a good team to arrive to this goal? Well, first we have a founding team that we started together 2 years ago that really gathers all the business, technical, and scientific skill to develop this reliable quantum link solution. I have myself a background as an engineer and physicist. After my PhD, I transitioned to entrepreneurship by creating Welinq, a company I've been leading for 2 years now. And I'm joined in this project by 2 scientific advisors, Julien Laura, who's professor at Sorbonne University in Paris here. He's really a world expert in the quantum memory hardware. It's in his lab that they have obtained the world record in efficiency in 2020. And we have also Eleni Diamanti, who's Senior Research Director at the Laboratoire d'Informatique de Sorbonne Université in Paris, and she's really a rock star in the field of quantum information protocols ranging from quantum communication to distributed quantum computing. And we have, as well as the 4th horseman of the quantum memories, that's how we are called, Jean Lothiego, who is head of business development and sale at Welinq. He's present at the conference today if you want to discuss with him. And he has himself a very strong background in the engineering and sale of quantum systems. And this is where we started 2 years ago, but since then Welinq has very well grown. We are now a team of 15 full-time employees working in our facilities in Paris. We have set up a visionary scientific committee that we are going to announce in the coming weeks with, in particular, the physics Nobel laureate Alain Aspect that most of you know. We have secured a very first funding to start our activities and develop our product of quantum memory, and all this typically in 2 years. Where are we going now for the coming months? Well, as I was saying, we are going to deliver our quantum memory by end of this year, and we are really looking forward to deploy it in real-world environment with our partners. We will double our workforce by end 2025. We are targeting 25 to 30 employees at Welinq by end of this year. So if you know very talented physicists, engineers, or anyone who wants to join our initiative, feel free to put them in contact with me. And in addition, as there are some investors in the audience, we are also going to do our second round of investment in this year. So if you are interested as well in joining Welinq as investors, please feel free to reach to our team. That's all. So what can we provide to you today? Well, as I was saying, we have today the world's most performant quantum memories that we want to put in the hands of our customer to deploy new use cases, new application. So this is really something that we are really looking forward to do, setting a partnership with providers of quantum computing all around the world, high-performance computing centers, industries who are users of quantum computing. So if you want to work with Welinq on all these topics, please feel free to reach us. Thank you very much.
Thank you, Tom. This is super impressive. So we have a few questions. Feel free to ask them also right now. So the first question is, what is the typical bandwidth of your solution, meaning the quantum state transport per second through the network?
So there are 2 things. There's the bandwidth of the quantum memory, typically the size of the wave packet that we can store. Today we have a quantum memory that can store photons up to 5 megahertz, but we are working on increasing the bandwidth of our quantum memory to go to the gigahertz regime. And this is actually one of the reasons that we are partnering with providers of quantum computing or other person is that we are eager to get your requirement in terms of performance of the quantum memory, because we can push some performance indicator depending on your needs. So we can play with the bandwidth from tuning from few megahertz to gigahertz, and then the rate at which you create entanglement between your network is going to depend on many parameters. You have the quantum memory, you have the single photon source if you do entanglement-based quantum network, single photon detectors. What we are targeting and this is where you can beat direct propagation in fibers, is that starting with 25 kilometers in length, that you should beat the rate of direct propagation in fibers by using repeater-like architectures with quantum memories. This is typically what we are targeting at Welinq.
Nice. We have. Is it more difficult to create a link for some type of quantum hardware? More difficult for some than others?
So the requirement on the quantum memory are going to depend on the QPU we want to plug in this quantum link here. I was saying, in principle, we can work on any type of quantum hardware. And really what is going to change depending on the QPU you are going to plug is how you extract this photon. So you might need, for example, to change the wavelengths on your photon on the way. You might need to develop specific system to make sure that you can extract this photon with close to unity efficiency. And these are part of the work that we are doing with the providers as well. We can either work with other companies, partnering with them on some components for which we do not have the know-how that would be required, or we can also work together with common R&D program with the providers to develop together a solution.
And do you know which hardware you are going to tackle first?
So yes, the first three that we are going to tackle are neutral atoms, photonic QPU, and superconducting circuits. That's typically the three modalities we are going to connect first. Then, of course, based on this result, we can also address ions and silicon qubits. So these are typically our roadmap to address all these platforms.
Impressive. And now, one final question, more tricky. Do you think some quantum hardware makers will build their own link?
I guess some of them will try.
Uh-huh.
I guess some of them will try. What I was saying is that Welinq has really a unique positioning in terms of that we are building the hardware, but also the software up to the algorithm layer. So even a provider of quantum computing might not have the team to work on the algorithm in parallel. We have really this key and proprietary quantum memory that we really are convinced it's a game changer for quantum interconnection. I mean, I wouldn't be surprised that they are trying to develop their own solution, because this is, of course, the next bottleneck for scaling up quantum computing. But what we believe is that we can always help them to arrive to this objective.